It is given that water is in streamline flow along a horizontal pipe with a non-uniform cross-section. At a point in the pipe where the area of cross-section is 10 centimeters square, velocity of water is 1 meter per second, and pressure is 2000 pascal. The pressure at another point where the cross-sectional area is 5 centimeters square is. So over here we are considering a horizontal tube through which some amount of liquid is flowing. So we know that if it is flowing through a horizontal tube, the gravitational potential energy with respect to a reference line, we can take it as same at both the points. So non-uniform cross section at a point, the pipe where the area of cross section is 10 centimeter square. So take it as over here the area is nothing but 10 centimeter square. Velocity of water in meter per second is 1 meter per second. And the pressure at point is over here, pressure is given as nothing but 2000 pascal. The pressure at another point, RM is to find out the value of pressure at another point where the cross-sectional area is 5 centimeter square. So first of all, by using continuity equation, we can find out the value of velocity of liquid over here. Take it as it is V2. So according to continuity equation, we can write this A1 V1 is equal to nothing but A2 V2. So the value of V2 can be written as nothing but A1 V1 divided by A2. The value of A1 is nothing but 10 and V1 is 1 divided by A2 is nothing but 5. So you can write velocity over here is 2 meter per second. So now we can use Bernoulli's theorem between point 1 and 2 and we can find out the value of pressure at point 2. So by using Bernoulli's theorem, we can write pressure at point 1 plus half into rho into V1 square plus rho into G into H1 is equal to pressure at point 2 plus half into rho into V2 square plus rho into G into H2. In this situation, with respect to a reference line, as the tube is horizontal, the gravitational potential energy are same, or H1 and H2 are same. So gravitational potential energy term is going to get cancelled. Then RM is to find out the value of pressure at point 2. So this we can take it as P1 plus half into rho into V1 square minus, and from left hand side we can write it as V2 square is equal to pressure at point 2. Now we can just substitute the values. P1 is given as nothing but 2000 plus half into density of water, we can take it as 10 raised to 3, and V1 velocity is given as nothing but 1. So it is 1 square, it is 1 minus V2 which is equal to 2 square which we can take it as 4 will be the value of P2. So we can write this is equal to 2000 plus this we can take it as minus 3 divided by 2 is minus 1.5. So we can write this is equal to 1500. So 2000 minus 1500 will get us nothing but 500.